Hi, everyone. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. Today, we're going to start chapter 11 on quadratic functions. And section 11.1, we're going to introduce those functions and their graphs. So we're going to talk about different aspects of quadratic functions, etc. So here are some objectives. Again, we're going to work with graphs of quadratic functions, and then we're going to solve some min-max applications specifically involving the vertex of a parabola, which is a quadratic. So first of all, what I wanted to do is I wanted to define what a quadratic function is, or what it looks like. So it can be written in this form where we have a function f of x is equal to a x squared plus bx plus c. So a, b, and c are constants. Okay, so you can think of them as coefficients here where we have the variable terms, and then c is just a regular constant. Basically, what we're looking here, or what we're looking for in a quadratic, is it has a degree of 2, right? Where that means that the exponent or the highest exponent is 2. So any time where you have a function where there's an exponent of 2 and nothing bigger, it's going to be a quadratic. It's going to be in the shape of a parabola. So a parabola, I'll just spell that out. And that looks like, something like this, right? Or something like this. And that's an arrow. And we'll learn in this section that when it's facing upward like this, or in the U shape, that our first constant or coefficient is greater than 0. And when it's down, or facing down, or opens down, we should say, a is less than 0. Obviously, if a was 0, then this term would not exist, so it would not be a quadratic function because 0 times anything is 0. So I wouldn't have an x squared term. So let's talk a little bit more about quadratics and parabolas. Okay, so again, the graph of any quadratic function we can also call a parabola. The vertex of a parabola is the lowest point on a graph of the parabola that opens upward. And it's the highest point on the graph of a parabola that opens downward. So if I go back to this slide, the vertex here on this parabola is going to be right here. It's the lowest point on a quadratic, right? That opens upward. And here it's the highest point on a quadratic or a parabola that opens downward. So let's just kind of go over some basic graphs here of some parabolas here. So the graph of a parabola is actually it is symmetric with respect to the vertical line through the x value of the vertex. So in this blue graph here, if y equals x squared, this is our function. Okay. There is a line, and we call that line the axis of symmetry, that splits this parabola into two kind of equal parts here. So it cuts it in half. Okay. And the vertex is always here, again, kind of in the middle. It's either the highest point or the lowest point based on if it opens up or down. And the axis of symmetry always goes through the vertex. Okay, so the vertex in this case is at the origin, or the point 0, 0. And the axis of symmetry here is this pink line. Okay, and I could label those. Okay, well, I have the vertex 0, 0. The axis of symmetry would be this line, and it is actually the line x equals 0, right? Because every point on this line, x is equal to 0. And then that's pretty much it. So two main things that you need to know here are where's the vertex and where's the axis of symmetry. So here's one that opens down. Here's a parabola that opens down, right? The axis of symmetry, again, is basically the y-axis, or x equals 0. I know that's kind of weird, right? Y-axis and then x equals 0. Well, yeah, that's how it is. Every point on this line, x is equal to 0, right? And the vertex is at 0, 2, right? It's the it would be the maximum point of this parabola, right? So this parabola opens downward, and our vertex is right here, kind of at the tip of it. Here's another parabola. I don't have a, again, the only formula we really had for these here was y equals x squared. I didn't give you a formula, basically, or not a formula, but I didn't give you an equation for this function, and I didn't give you an equation for this blue function. But we can tell here that the vertex of this particular function is at 2, -1, right? So it's the minimum point of this parabola. And the axis of symmetry is a line that goes through it. So again, it makes the parabola symmetric, right, on either side. It kind of cuts it in half. And that is x equals 2. And I actually give you that there. Generally, we draw the axis of symmetry with a dotted line. You can also use a solid line, but generally it is with a dotted line. The reason why they have it solid here, I think, is because it is on the y-axis. So they just want it to be clear that, yeah, that is the axis of symmetry. So a little bit long-winded there, but hopefully that helps a little bit explain or to explain some of this. So let's go through some of these examples now. So, and maybe I'll do this in red because we have that blue line there, or blue function. So use the graph of the quadratic function to identify the vertex, axis of symmetry, and whether the parabola opens upward or downward. So again, this parabola is has a vertex right here, right? We can see that that's kind of the minimum point of that parabola, and that is basically going to be our vertex here. So we're not focusing right now on the equation of the function. We're just focused on vertex, axis of symmetry, and whether it opens upward or downward. Obviously, we can see it's opening upward. But the vertex there is going to be at the point, well, what is it? It's -2, -1, right? And then the axis of symmetry, and maybe you noticed this before, but the axis of symmetry is always going to be x equals something. And it's actually always the, and I'll just kind of draw our axis of symmetry again. Generally, we draw it with a dotted line. But it's always actually going to be the x point of our vertex. So it's going to be x equals -2, right? And that is, again, that is one point where x equals -2, and that happens to be on our graph, but up here, x is equal to -2 as well. So just so you know, and then how does it open? Well, it opens upward, right? Or just up. So let's fill in these same things. So we need to know the vertex. We need to know the axis of symmetry. That's 3 words there, axis of symmetry. And then we need to know how does it open, right? So the vertex here of this parabola is way up here, right? It's at 0, 4. And we always write it as a xy point. Axis of symmetry is always the x value of the vertex. So x equals 0. If you want to, we can kind of draw it in here. See why they had a solid line before when it's on the y-axis. And then this one opens down. Okay, so what do we know when we would try to do figure out what the equation of the function is? This would be f of x equals, well, a is going to be positive here, right? Ax squared plus bx plus c. A is going to be greater than 0. But here, this is going to be -ax squared plus bx plus c. So a is, the point is a is less than 0 in this case when it opens downward. And we'll get into that here kind of next. So we got a couple things to do before writing equations or working with the equations of those. Let me switch back to blue. So use the given graph of f to evaluate the expressions. So this is a homework question. The book didn't really cover this well. And this is kind of a review, so to speak. But I still think it's, we didn't cover it that much, so we need to cover it. So kind of recall here, everyone, that when we have a function f of x, right, some people kind of consider that equal to y. So f of x equals y, and that's really kind of the point here when we're doing these. So if I have f of 1 and I'm trying to find what that equals or what that evaluates to, that is the x point here. 1 is the x point, and I want to know what y is when x is 1, right? So basically this means what is y when x is 1? Okay, that's what this is saying. So here is our function or our graph of our parabola here. We need to know what is the y value when x is 1. Well, x is 1 right here, right? X is 1 right there. So what is the y value there? Well, it's just 0. Okay, we can see that here's the x-axis, here's the y-axis. Y is 0 right there. So that point is at 1, 0. And then f of 4, okay, what is that? Well, here is where x is equal to 4. Where is y equal to 4? Well, it would be right there. So this is the point 4, -3. So when x is 4, y is -3. All right, next thing we're going to get into, again, before we get into working with that equation of a parabola, is the vertex formula. Okay, so this is a formula. Okay, and it even says it here. This is a formula. The x coordinate of the vertex of our quadratic, right? Y equals ax squared plus bx plus c is given by this. Here it is. Okay, x is equal to -b/2a. So what does this mean? It means that this is the x coordinate, right, of the vertex. And it even says that here. I just wrote it again just to emphasize it's the x coordinate of the vertex. That's the formula to find it, if you know what the equation of the quadratic is, right? And then to find the y coordinate of the vertex, you just substitute that x value back in. So some people kind of say, all right, I'm trying to find the vertex, right, of our parabola, just given the formula for it, not even graphing it. Okay, I'm given the equation of the parabola or the quadratic, right? And I want to know what the vertex is. Well, I'm just gonna, find it by doing -b/2a, right? That's our x value. And then I substitute whatever this is back into the original equation. So back into this f, right? Again, y is equal to f of x. I substitute that in to find the y value, or f of -b/2a. Okay, that's the vertex. So let's go ahead and let's practice that a little bit. So find the vertex for the graph of f of x is equal to 2x squared plus 8x minus 3. And we're going to support our answer graphically. So we are going to go into Desmos to do that as well. So the first thing is we need to find the x value of it, x value of this parabola. Again, how do I know it's a parabola? Because my leading, or not my leading, but my highest degree is 2, right? I can just automatically, oh, we have an x squared term. There's no other, higher terms in there. Automatically, it's a quadratic or a parabola. So what is A equal to here? Well, A is equal to 2. What is B equal to? Again, this is A, right? This coefficient or this constant is B. So B is equal to 8. And then what is this guy? Well, C is equal to, you also have to bring in the term in front of it. So, or that, not the term, the sign in front of it. So C is equal to -3. We don't really need C, but just because, right? All we really need here is A and B. So step 1, right, would be maybe to define A, B, and C. Okay, if you don't really need C again. But our next step is to, again, find the X value. Okay, so what is the X value of the vertex? So X value of vertex, okay? And what we do is we take that formula that we had on the last slide and we substitute everything in. So we plug it in. So we know the formula is negative b over 2a. So we have -8 over 2 times 2. And that simplifies down to -8 over 4, which is -2. So I know that the X value of the vertex is -2. Let's find the Y value. Y value of vertex. My handwriting needs a little bit of help today. Sorry about that. This is Y value of vertex is equal to what? Well, it's equal to f of that value. So I substitute it back into the original. Okay. So I take the -2 that I just found, I plug it in for all the x's in our original quadratic. So I have 2 times -2 squared plus 8 times -2 minus 3. And that's going to give me, let's see, -2 squared is 4. 2 times 4 is 8. 8 times -2 is -16. And I have a -3 here at the end. So I have a -11. So what is the vertex? Okay, the vertex is -2, -11. Okay, and what I'm going to do next is I'm going to support this answer graphically. And I'm not going to draw a graph on here, but what I am going to do is I'm going to go over to Desmos. And I am going to graph this. So I have 2x squared plus 8x minus 3. And again, here is our quadratic equation. And I notice that the vertex right here is -2, -11. And Desmos is kind of nice. It does show some of these points here. When you have a quadratic, it's going to have these little dots here. So it's gonna tell you, oh, this is the point where your vertex is, -2, -11. And now we're not talking about it in this section yet, but it also gives you the y-intercept. So where this quadratic or parabola crosses the y-axis, 0, -3. And then also, in this case, it has 2 x-intercepts. And really, either a parabola is going to have 2 x-intercepts or it's going to have 0 x-intercepts. So if this was above the x-axis here, going upward, it wouldn't have any x-intercepts. If it was below the x-axis and it was opening downward, then yeah, it wouldn't have any x-intercepts. But there are ways and equations to figure out x and y intercepts. And we've actually kind of learned those, but we're not going to talk about it quite yet in this section. But let me just briefly mention, that if you have a y-intercept, what is your x value always on the y-axis? It's always 0. So if I wanted to figure out the y-intercept, I would just substitute 0 where you see x. And we can see it would be 0 times 0, and then I have a -3. So there it is, 0, -3. And then there are ways to figure out these x-intercepts. And how do we do that? Well, we do it actually by factoring. So I would actually factor this. And actually, this isn't going to factor very well. We can see what our x values are there. And that's going to be the point later on in this chapter when we talk about the quadratic formula. Would be another way to find where those intercepts are. Or we could also complete the square as well. But in this case, it would be a little bit difficult to complete the square. But we would use the quadratic formula, which we will learn later this chapter on how to do that. But let me go back to the PowerPoint. and kind of get back on track here and continue on. So let's do it again. So let's in this case, what we're going to do is we're going to try and identify the vertex, the axis of symmetry on the graph, and then we're going to graph this. So basically what I'm doing here, let me see if I click ahead. Yes, I did include a table. So another way to do this is to kind of make a table. And again, we have an XY table. And again, our Y value is really f of x, right? It's this equation x squared minus 2. And you can start picking x values here to try and figure out what or where the vertex is. And I'll just say for this one, we can start maybe up here, -3, -2, -1, 0, 1, 2, 3. And when we substitute those in here, we're actually going to be able to graph this quite nicely. Again, if you don't pick these x values, that's fine. You'll still probably be able to, figure out kind of what the graph is doing and try to figure it out that way. But I am not against you at all, not against using Desmos, okay? But I do want you to know how to verify your vertex, okay, to kind of double check it. So you can use Desmos to graph this, okay? And let me actually do that here. What is it? X squared minus 2. So let me go back over to Desmos. Okay, the graph of this is x squared minus 2. So you can definitely use this. Oh, here's the vertex, 0, -2. You can do that, okay? You can figure it out using Desmos, but you need to be able to verify it. So you do need to be able to use the formula x equals -b over 2a to find the x value, and you need to be able to substitute it back in to find the y value, okay? And I'm going to demonstrate that here. So this table is just going to show you the same graph, basically. Once I substitute all these in, it's going to show you the same thing, basically, as what Desmos just did, okay? But let's go ahead and do this here. So I have -3 squared is 9. 9 minus 2 is 7. -2 squared is 4. 4 minus 2 is 2. Let me just kind of go a little bit quicker here. I'll just kind of run down. You can double check these here, but 0 squared is 0, minus 2 is -2. Oh, there's our vertex. Like Desmos told us, this is going to be -1, 2, and 7. It is symmetric, right? So here's our vertex, right? 0, -2. We notice, oh, here, these are the same thing. The y's, right? 7, 2, -1, -1, 2, 7. Okay. That happens, right? If it's symmetric, it's going to be the same thing on either side. So if you're a distance of 1 away from your vertex here, again, we know this is the vertex without verifying. We will verify it in a second. But we know this is the vertex. This is a distance of 1 away from the vertex, both of these, -1 and 1. And they're the same value, -1 and -1. -2 and 2 are both 2 away from their vertex at 0. And look, they're both the same, 2 and 2, and then 7 and 7 for when you're 3 away. So let's go ahead and graph that quick. I have -3, 7. It's going to be right there. Always tries to bring up another chart, so sorry about that. This pen sometimes bothers me. It's not good at making circles or dots. Yeah, see what I'm talking about? -1, -1, 0, -2, 1, -1, 2, 2, and then 3, 7. So it looks somewhat like that. Drawing this is going to be even more tricky here, but it sort of looks something like that as we saw in Desmos. This is why I have Desmos. Okay, this is why you can use it. But let's try and verify this again, okay? So I know right away here from Desmos that the vertex basically is 0, -2, and the axis of symmetry, again, is always the x value here of the vertex. So x is equal to 0, right? It's what splits this in half. It's symmetric on both sides, okay? But let's verify it here. So let's verify. Well, we know x is equal to negative b over 2a. This is your x value of the vertex. Okay. Well, what is what is a, b, or what is a and b here? Well, a is equal to 1, right? We have a 1 in front of the x squared. Recall that I have y equals ax squared plus bx plus c. This is our equation of the parabola or the quadratic function here, right? Well, there is no x term. That's okay, right? This is the same thing as x squared plus 0x minus 2. Okay, these two things are exactly the same. Okay, well, what is the b term? Well, the b is 0. Okay, or sorry, what is the b constant? The constant is 0 here for b, right? You could have c in here. C is -2. It doesn't really matter. But when we substitute this in here, we know b is 0 and a is 1. Then yeah, this is going to end up being 0. So the x value of the vertex is 0. I just verified that. Okay. Now let's verify that the y value is in fact -2. Well, I plug 0 in for the original equation for x. So I have 0 squared minus 2, which is 0 minus 2, which is in fact a -2. So yes, the vertex is in fact 0, -2. And then the axis of symmetry is always the x value of the vertex in an equation form. X is equal to 0. Let's do another example. Identify the vertex and the axis of symmetry on the graph, and then graph. Again, you can make a table, okay? You don't necessarily have to make a table. I just want you to know maybe for your homework, right? How to do this. So, you have your x value. Oops, it's drawing everywhere because I clicked on something that I wasn't supposed to. There we go. So I have my x value, and then the y value is your function, right? You're basically getting your output by plugging it in, right, to this function. And so you can kind of pick your x values. I'm going to give you good x values here that are going to make this work well. And actually, I'm doing the wrong ones. It's for a different problem. Good x values here for this one are 0, 1, 2, 3, 4. Okay. And when we substitute these in, so I plug 0 in for this, I'm going to get 0 minus 2, which is -2. -2 squared is 4. And I have that negative on the outside. So -4. This is going to be -1. This is 0, -1, and -4. Okay. So where do you think your vertex is? Well, it's going to be right here, right? In this case, it's not always going to be, if you're choosing your own and you don't know how to get good x values right away, or you can't, come up with those, whatever, you can still figure out your vertex this way. It might just take you a little bit longer, but it's going to look something like this. 0, -4 is down there. 1, -1, 2, 0, 3, -1, and 4, -4. So this one's going to be opening downward. And we could have figured that out right away, right? Because our value right here is negative. But, just so we know here. But let's go ahead and let's verify, right? Let's verify that the vertex is at 2, 0. And that the axis of symmetry is in fact what? Well, it's x equals 2, right? Because this guy is the line that cuts this in half. Okay. Right, again, this is a line, x is equal to 2. So let's go ahead, let's take our g of x equals negative parentheses x minus 2 squared. Now, I can't really figure out, well, what is my A, what is my B, what is my C, because I haven't, solved, or I haven't simplified this yet. I need to kind of factor or FOIL this out to be able to do that. So if I have negative times x minus 2 squared, I'm going to split this up, right? I have x minus 2 times x minus 2. Then I need to FOIL this out. I'm gonna not do anything with the negative yet. I'm gonna FOIL the two parentheses out. So I get x squared minus 2x plus 4. See how FOIL and all that stuff kind of comes back, and factoring and all this. And then I combine like terms. I have negative 2x and negative 2x is negative 4x. And then I'm going to distribute that negative. So it's just going to change all the signs on the inside of the parentheses, and we can now get rid of those parentheses. And then I need the x value of my vertex. Okay, again, I'm verifying this. The x value is, again, equal to that negative b over 2a. That's a formula. And so I have negative 4 over 2 times negative 1, right? Because a here is negative 1. It opens downward because a is less than 0. And then b is 4. And this is going to end up being 2, right? When I have negative 4 divided by negative 2. And then I substitute it back in. So my y value is equal to g of 2. So plug into our original equation where we see that x value, and 2 minus 2 is 0. So it's 0 squared, which is 0. So yes, I just verified that the vertex is in fact 2, 0. And then I know that the axis of symmetry, right, is x is equal to 2. All right, these are taking a little bit longer, and you can also verify that last one on Desmos. Let me just go ahead and do that. I might not verify the next one, depending on time here, but I have x minus 2, negative x minus negative times quantity x minus 2 squared. And here's the vertex. It's at 2, 0. All right, let's go back then to, I think I have 3 more problems left, 3 more questions. So I'm not gonna spend the time to fill out this graph here. I will kind of give you what you could use for this in order to use the table. But if you wanted to do this, you definitely could. I'm just gonna fill this out. Okay, and here are the x values that are going to be the best to use here. Negative 2, negative 1, 0, and then 1, 2, 3, 4. And that's going to end up giving you 5, 0, negative 3, negative 4, negative 3, 0, and 5. And again, here for your vertex, we need to know a and we need to know b, right? So a is positive 1. It's the constant in front of x squared. B is equal to negative 2. It's the constant in front of x, including that sign. And again, for your vertex, the x value of the vertex is equal to this formula. X is equal to negative b over 2a. And b is a negative 2, and a is a 1. So it's going to be positive 2 over positive 2, which is 1. And then the y value of the vertex is equal to, well, I'm going to substitute, right? So h of 1. So I'm going to plug in 1 everywhere that I see an x. That's going to give me 1 minus 2 minus 3, which is negative 4. So the vertex is at 1, negative 4. Okay, and what you could do really for these is you could you could identify the vertex first, and maybe that's what they want you to do, and I just didn't realize it at first here. But you could identify the vertex first. You could do your formula, then you could go to Desmos, kind of verify that, and then you can make your table if you want. I don't care what order you do it in. I just want you to know how to do it. Okay, and to know how to do some of the steps here. And so the vertex is at 1, negative 4, and the axis of symmetry, right, is at x is equal to 1. It's always the x value of the vertex. So, if you're graphing this, right away, okay, my axis of symmetry is here. It's at x is equal to 1. So I could draw a dotted line all the way down the x-axis, right? to draw my vertex, 1, comma, -4. Right, and then I could, you know, pick some points here. So, you know, if you're doing this, you could plot your vertex right in the middle, 1, -4, and then, you know, go on either side here. So, you know, do your 0 and 2, those are both 1 away, and I get 0, -3, and 1, or sorry, oops, 0, I just did that wrong. 0, -3 is, oops, I just did that. There we go. Sorry about that. 0, -3 right there. 1, -3 right there. And then I have, sorry, 2, -3. 3, 0. Okay, and then the other side, -1, 0. And then 4, let's see here. 4, comma 5. Struggling here. And then right there. Okay, and then you can draw your parabola as best as you can. There it is. And again, it opens upward because I know A is positive, A is greater than 0. So, all right, now, last thing I wanted to go over is maximum and minimum values here of the vertex. And then there's a kind of a word problem to do as well. But find the maximum value of the graph. F of x is equal to -x² minus 2x plus 3. Okay, well, what is the maximum value? Okay, well, this is a, this A value. Okay, A is, sorry, oops, I meant to do less than. A is less than 0, right? It's not erasing. Oh, I see what it wants to do. Can we get rid of that? No. Okay, here we go. You guys kind of saw some of the wording that I wanted here, but A is less than 0. So I know that it has to open downward, right? Well, that means it has to look like something like this, right? And the maximum value is always at the vertex, right? So what is the maximum value? Well, if it opens downward because A is less than 0, it's the highest point on the graph or the vertex. Well, let's go ahead and find what that is here. So I know, what is A? A in this case is -1, right? It's the constant in front of x², and B is -2. So let's go ahead and find the x value of the vertex, and that's equal to -b over 2a. Okay, so I have negative, and then -2 on top over 2 times -1. And this is -2 over 2 times -1 is -2. So -2 over -2 is 1. And then I have the negative out front. So it's just -1. And then the y value here is going to be, when I substitute -1 back in, for every x value that I see in that quadratic. Let's do a little math here quick. 1 squared is 1. I have a negative out front. So it's -1 minus, or -2 times -1 is +2, and then +3. So -1 + 2 + 3 is 4. And so what does that mean? The maximum y value is right here, okay? Max y value is at 4. What do you suppose is the minimum y value on a graph where a is greater than 0? Okay, well, just a couple points here. So it's a is greater than 0, so it's going to be facing upward like that, or opening upward. And I don't really know what the minimum y value is. I would have to figure that out. But just to kind of, the point is a is greater than 0. It is going to open upward. But then in order to figure out where the vertex is, I am going to need to know either the graph, right, what it looks like, or the equation of the quadratic. And then I could substitute. And there's the graph. I just kind of filled it in there. All right, here is a word problem. Very common word problem that I'm going to show you here. But really, it's a lot simpler, I think, than it kind of seems. So if a baseball is hit into the air and its height, h, so its height is h, in feet after t seconds, and it can be calculated by this quadratic. H of t is equal to negative 16 t squared plus 64t plus 2. So this is a quadratic, okay? You're imagining, right? You have somebody, my pictures are absolutely terrible. Okay, they have this baseball bat, okay? They're hitting a ball, okay? Let's say they swing and then boom, they hit the ball. Okay, and maybe they connect with that ball. Maybe they connect with the ball right about there. Okay. Well, the ball is going to go up, right? Ball goes up and then it eventually goes back down. Okay. That's going to form a quadratic. Okay, a parabola. The reason it's the leading constant's negative is because it's going to be that kind of that facing downward shape, right? Well, we need to know what is the height of the baseball when it is hit, okay? And how do we figure that out? Well, we know that the height when it is hit, let's read this. It's t seconds. So it's the height in feet after t seconds. Height in feet after t seconds. So when it is hit, it hasn't been in the air yet. Okay, so it's been 0 seconds. So t, or our time is going to be equal to 0 here. And then what I would do to figure out the height, or h, is just substitute 0 everywhere that I see a t. So I'd have negative 16 times 0 plus 64 times 0 plus 2. And we know that this is going to all be 0, this is going to be 0, and then this is a 2. So what is it? What's the height? It's 2 feet. 2 feet really at 0 seconds. Okay, I just put that at 0 seconds just to emphasize that that's when it's hit. Now, what is the maximum height of the baseball? So the maximum height of the baseball is going to occur right here, right? Wherever the vertex is. Okay, so this guy, right? Our vertex is equal to the max height. So let's figure that out, okay? Well, I know our equation for the vertex. So let me just write down this equation of our quadratic again. I know that x, the x value of the vertex x value is equal to what? It's equal to negative b over 2a. So I know that it's negative what? Negative b, negative 64. 64 is your b value, right? And then what is your a value? It's negative 16. And this is going to give you negative 64 over negative 32, which is positive 2. It just so happens to be basically a coincidence that these are both 2. This is not always going to match. Okay, but your x value of the vertex is going to be 2. And then what is the y value? And y is really what we're worried about, because when we find the y value, okay, that is what in this case? That is h of t. H of t is equal to y, right? What is h of t? H of t is the height, right? It's the equation for the height. So when I find my y value, that's going to allow me to find the maximum height. It's going to give me the y value of the vertex, okay? Time is always a x-axis sort of thing. Height is always a y-axis sort of thing. It's like when we talked about variables as independent versus dependent. Time is independent right? It doesn't depend on anything, but the height depends on time. The height of the baseball depends on how long it's been in the air. Okay, so it's dependent. It's a y value. So let's go ahead and do that. So let's figure out the height when time or t is equal to 2. Okay. So I have -16 times 2 squared is 4. 64 times 2 is 128 plus 2. So I have -64 plus 128 plus 2. That is going to give me 66. And what is it? It's 66. It's h of t. It's the height in feet after t seconds, 66 feet. Okay. So again, our vertex is at 2,66. This was a coincidence. This was a coincidence. Coincidence. That these were the same thing. So that's not always the case. But our maximum height here is the 66 feet. All right, that is all that I have for you guys. So that's 11.1. Again, kind of an introduction to quadratic graphs and their functions. It was probably a little bit more long-winded than I wanted it to be, but I hope that kind of builds the foundation here for the rest of chapter 11. When we're going to be working more with numbers versus graphs. Okay, so you kind of understand with this where some of this kind of comes from, and hopefully that helps you make a little bit more sense. But we'll see you next time for 11.2, and have a great rest of your day.